Welcome to my channel. We are looking at integral calculus, and in this video I'll give various examples that will enhance your skills in integration. So I'll begin with what we already know, that if you're given an integral of this form where n and a are constants, and you are asked to integrate it, generally this is how we give the solution. That it will be, we raise the power by 1, so this is x raised to n, so it will be n plus 1, then divided by the new power, then add a constant of integration, c. So that's what we just do, and we'll look at various examples before we start doing other types of integration. So what we are saying is, when you are given the integral of x raised to n, a is any number, is any constant, n is also another constant. The integral of this, the solution to this would be, we just raise the power by 1, so it's ax n plus 1. So this is our new power, and we divide by this new power. What I've stated here is that this rule is only applicable when n is not equal to -1. So n should not be equal to -1. So what I'm saying is, we are not using this rule to do integration of this kind, where n is -1. So when n is -1, we'll come up with another rule for doing that. So let's just look at a few examples. And the first example here is, determine the following indefinite integral. And I hope you know the word indefinite means that these are integrals without limits. So we do not have, these integrals have no limits. For example, you're not saying that you're integrating from what point to what point. Now, so we want to look at these examples, and some of them are easy, like the first one is very easy. As we said from our rule, is that we shall add 1 to the power and divide by the new power. So as seen, this a, the solution to this a, when you raise 1, when you raise the power by 1, so this is 3 by 1, and divide, so the new power is 4, divided by that 4. What you have is 7 out of 4, x raised to 4, and then add a constant integration. So the first one is very easy. The second one is also easy. Then we just add 1 to the power, so the solution becomes 3 out of 7, x raised to 7 plus 6. So when I add, this is 6. 6 plus 1 gives me 7. So that is why I get x raised to 7 and divided by that new power. The same to this one is also very easy. We're just adding 1 to the power. So let me show you my working, that I done this one earlier. So what I was getting as my workings are here. These are my workings. So for the first one, I said you just add 1 to the power, equals 4, and you divide by that 4. Then add a constant of integration. The second one, the same thing. Add 1 to the power, gets 7, and then divide by 7, and then add constant of integration. The third one is also that way. That's why I said add 1 to the power here, add 1 to 4. So this part becomes 7x raised to 4 over 4. And we also do this other one. Add 1 to the power, you get 3. So it will be 2 out of 9, x raised to 3, then divided by 3. And that is what you're seeing here as 2 over 27, x raised to 3, because 9 times 3 is 27. Then these are constants. There's 13, x raised to 0. 13 x raised to 0, because I know that x raised to 0 will be 1. So this is 13 times 1. So I just add 1 to this power and then divide by the new power. So this gives me 13x, and that's what I have here. Then plus c. So therefore, what you're saying is that the integral of a constant would be 17x plus c. Or for this one, the integral of a constant 13, the x is 13x plus c. So that's what I've used here, that when you're integrating a constant, just add the x. With respect to x, just add x to that. And let's look at part D of the examples. Now, so part D, I can see that this division is a division. So the first thing I'll do is to divide through first before I integrate. So what I have is 7 x raised to 5 divided by 5x squared, then plus 13 x raised to 2 divided by 5x squared, the x, the integral of this. So when I divide this, what I would get will be 7 out of 5 x raised to 3 plus 13 out of 5. These are constants, then the x. So this is what I have to integrate. This is what I have to integrate. And this is what you're seeing here, 7 out of 5 x raised to 3 plus 13 out of 5, then the x. Now to integrate this, you say you add 1 power. So this becomes 7 out of 5 x raised to 4, then divide by that 4. Then the other one is a constant, so it will be 13 out of 5 x, then plus c. But now 5 times 4 is what is giving me this 20. So I have 7 out of 20 x raised to 4 plus 13 out of 5 x plus c. That's how I did that. Now what about this one? Again, I have to do the same. I have to divide. So that is the same as 11 x raised to negative 3 dx. And so when you add 1 to the power, you'll have 11 x raised to negative 3 plus 1. And this gives you negative 2. So you divide by that negative 2 and then add a constant integration. And so that gives you 11x raised to negative 2 over negative 2 plus constant integration. And if you want to write this in as positive, then you write it as negative 11 out of 2x squared plus 2. You can even leave your answer at this point and it still be correct. I wanted to express this as positive, this power, the power of x as positive. That is why I've taken it to the denominator. Now let's look at this other example. And we're just trying to simplify the questions that we have before we work them out. So what is this? What I'm seeing there is negative 11 out of 3, and this means fifth root, which can be written as theta 3 out of 5, raised to 3 out of 5, the theta. So once you simplify it, this way it becomes easy for you. So this will be the same as integral of negative 11 out of 3. We can take this theta raised to 3 out of 5 to the numerator. And when that happens, since it's positive in the denominator, the numerator becomes negative. The numerator becomes negative theta. So we can now integrate by adding 1 to the power, and so this gives you negative 11 out of 3 theta, negative 3 out of 5 plus 1, and this is 2 out of 5. So we divide this by 2 out of 5. Divide by 2 out of 5. Then we add a constant of integration. So when that happens, this is the same as you multiply by the reciprocal of this. So when you do that, you get negative 55 out of 3 theta raised to 2 out of 5 plus constant of integration. Oh, those are 2 there, so this becomes 6. This becomes beta. And so that is what I got. That's what you get when you do that. And let's look at the other question, the following example. Now this one, it's easier to first of all expand this, and you can see that it's a square, so you just expand. And how do you expand? 2 times 2 gives us 4. 2 times theta gives us 2 theta. And then theta times 2 gives us 2 theta. This one has given us 4. And now theta times theta gives us theta square. And so when you add this to get 4 theta. And that's why I have 4 plus 4 theta plus theta squared theta. Now integrating this a constant with respect to theta, you get 4 theta plus, add 1 to this. There's a 1 here, so you add 1, that becomes 2, and then divide by 2. And so you'd have 2 theta square, and then when you add 1 to this, you get 3, and divide by 3, you get a third theta cubed, then plus constant integration. That is how we do that question. So it was just easy. First of all, expand this. But there's another way of doing that. So we have various ways of doing this. Let's look at the last example. And this one, again, we just have to write it simplified first. And this is 11 minus m over the square root of m. And the square root can be written as m raised to a half. M raised to a half. Now divide it through. When you divide it through here, what you will have will be 11 m raised to negative a half minus m raised to a half the m. But this is what you have. Now to integrate this, in fact it's here, it's what I wrote here. To integrate this, just add 1 to a half. 1 to negative a half. These are power. So negative a half plus 1, you get a half. So our new power is a half. So what we now have will be 11 m raised to a half, and divided by this a half, you have 22m raised to a half. 22m raised to a half. That's what I have. And this other one, again, raise this one by 1. So it's a half plus 1. That gives you 3 out of 2. So the new power is 3 out of 2. And now when you divide the whole thing by 3 out of 2, divided by 3 out of 2, it's the same as multiplying by 2 out of 3. That's what we have here. Then you add a constant of integration. So this is how we do integration of this kind, where you are given ax raised to n, and where a and n are constants. So if you're given integration of this kind, this is what you do. And you've noticed that in some areas you are forced, first of all, to simplify the fraction. For example, in this case, you are forced to simplify, first of all. In this case, you are forced to simplify. We're looking at how to use algebraic substitution to integrate trigonometric functions. Now, so we'll look at various examples just to ensure that you'll grasp the concept of integration on trigonometric functions. First, I begin by giving you the following formulas, which you will find to be very much useful in our integration. Now, you've already done the derivatives of these trigonometric functions. For example, you already know that the derivative of sine of x would be cos of x, and the derivative of cos of x would be negative sine of x. But this time I'm giving you the formulas for integration. And now we must know that the integral of sine of x will be negative cos of x plus constant of integration, and the integral of cos of x will be sine of x plus constant of integration, and the integral of sec square x will be tan x plus c. The integral of cosec square x will be negative cot x plus c, and the integral of cosec x, cot x will be negative cosec x. The integral of sec x tan x will be sec x plus c. We have so many trigonometric functions, and we have so many, we can get the integral. So this is just a few, but as we progress with the integration, we come to learn several other formulas. Now let's look at examples on how to use the formulas I've just given you. So the first one, we want to look at the integral of 7 cos 5x, and then the second we shall look at. So we'll be looking at these questions. Now what you notice is that in my formula, I gave you the integral of cos of x dx, and this was sine x plus c. But in the first example that we are seeing here, this is not x, this is 5x. So this is more than x. And if this happens, then we must let this to be, because we only need one variable at this point. We just want something like x or u at this point, not 5u, not 5 theta, not 6 something. Just want u here. So for us to integrate this, the first thing that as I've already stated, we'll equate this to u and then differentiate. And that one I've done it for you. Let me just show you what I did. So for me to do the integral, this integral, since I noticed that this is not x, it's something more than x. So what I've done is I've let this to be u. So let u be 5x. And then when you let u to be 5x, differentiate this, find du dx. So when you find, or just differentiate, when you differentiate this, on the left you'll find du is equals to, on the right you'll find 5 dx. And then make dx the subject of the formula. Make dx the subject of the formula by dividing both sides by 5. That's what I did. That dx becomes du out of 5. We are now ready to integrate, and as I said, we want to use substitution. So we are substituting this. Instead of 5x, we substitute this with u, and instead of dx, we substitute this by du out of 5. And so that's what I did, that this integral is the same as this, 7 cos of u. So u instead of this. And then instead of this, I have du out of 5. At this point, I can take the constants outside the integral sign. And when you take the constants outside the integral sign, you can see that a constant is 7 out of 5. So it's 7 out of 5. We are left with the integral of cos of u du. This we know how to do it. We know how to do it because our formula has already told us that the integral of cos of x dx will be sin x plus c. So that means the integral of cos of u, if this is u du, if this is u du, then it will be sine of u plus c. So that is what we have. That we have 7 out of 5 sine of u plus c. So just substitute what was u. Our u was 5x. So that is our final answer, therefore, is 7 out of 5 sine of 5x plus c. So this 5x, we're getting it from here. It was the u. It was this u. And so that's how we integrate this. Now, what I will notice is that we can do this thing mentally because what we were given was 7 cos of 5x dx. We need to know how to do this thing mentally because a time will come when we have more complicated integrals. And when we come across this in our integration, at that point, when we are dealing with complicated integrals, we need to know how to do this part mentally so that we do not waste a lot of time. Now, so when I look at this, I can see the 7 and the 5 in my final answer. That what was here is divided by what was here. So I have 7 out of 5. Then I've just integrated cos to be sine and inserted this, inserted that, and then added constant of integration. So it's very easy when I look at this, and I've written that in some general notes here. I've written that in some general notes, and I've said generally, if you're given a function, the integral of L cos of bx dx, then the integral of this can be written mentally by taking A divided by B. A divided by B, then integrate this cos to be sine and insert x. Insert the x, then add constant integration. And that can be seen in our example B. Example B, we are told to integrate 12 cos of 7x dx. So without going through much work, we know that it will be 12 7. Then the integral of cos is sine, and just insert 7x, then plus constant integration. And so that's how we do it. And let's look at a different example. That was example C. Example C here. The question is, integrate this. This is what we want to integrate. But just as in our example A, what we know how to integrate is this. We know how to integrate sine of x dx. And we know that this is negative cos of x, then plus constant of integration. This we know from the formulas we're given above. But looking at this question here, this is not x. This is more than x. So we must equate it to u, just as we did in the first example. We equate this to u and then differentiate. So that's what I've done. Let u be 4x. Then differentiating this, the left side, differentiate the left side, I have du, and the right side, I have 4dx. 4dx. Make dx the subject of the formula. By dividing both sides by 4, you will find that dx equals du out of 4. We are now ready to integrate by substituting this with u and this by du out of 4. So that's what I did here. So it's the same as the integral of 9 sine of u. Instead of dx, we have du out of 4. And then as in the first example, take the constants outside the integral sign. Then the constant here is 9 out of 4. So 9 out of 4, the integral of sine of du. But what is sine of u? The integral of sine of u. The integral of sine of u is negative cos of u plus a constant of integration. So this, doing that, we get negative 9 out of 4 cos of u plus c. We just need to substitute the u here because it was not in our original question. What was in our original question was 4x. So bring the 4x back. And what you have is a negative 9 out of 4 cos of 4x plus c. This is our final answer. Now, again, we can generalize this, and we are looking at this question. We are saying that what we had was 9 sine of 4x dx. And when we look at our question, at our answer, what we have is 9 out of 4. So the constant here over the constant, so 9 out of 4. Then the integral of sine is a negative cos, and insert the 4x, then plus constant integration. So we can write the answer mentally, actually, without going through much workings. So I've written that as a general note, and I've said generally, given the integral of a sine of dx, the answer to this can be written mentally as negative a out of b cos bx plus 2. So I've given one example to show this. Given one example, that is part D. And in part D, we are asked to get the integral of 2 sine of 9x dx. So whenever I say this, I realize that this is not something to waste a lot of time working out. The answer will just be negative 2 out of 9 cos 9x plus c. The answer can be written straight away. Now let's look at another example. So we're looking at example E, and we are asked to integrate this. And there's something that we know from our formulas above. From our formulas above, we know that the integral of sec squared theta d theta is the same as tan theta plus constant of integration. So that we know. But this is theta. What we have here is 9 theta. So that means this must be equated to u. Yeah. The examples are now clear. We've already seen 2 examples above how we've been doing that. That whenever this is more than what we have here, or whenever it's different from what we have here, then we have to equate it to u. So let u be 9 theta. Differentiate both sides. You get du equals 9 d theta. Make d theta the subject of the formula, and if that happens, you have divide both sides by 9, and then you get d theta is du out of 9. Now come back to your integral, and this is the integral. So just substitute. Where there is 9 theta, put u. And where there is d theta, put its equivalent, which is du over 9. Du over 9. So then take the constants outside the integral sign. Our constant here is 4 out of 9. So I have 4 out of 9. Integral of sec squared u du. But this we know from here. We know that it's tan u plus c. So this is 4 out of 9 tan u plus c. Then bring back the equivalent of u was 9 theta. Because u was not in the original question. What was in the original question was 9 theta. So bring 9 theta back. And this is supposed to be 9 theta, not 9x. 9 theta plus c. So again, you can generalize this. And you can see it's 4 out of 9 tan. 4 out of 9. So you're just taking from here, from this. You can write the answer mentally. It's 4 out of 9. The integral of sec squared is tan. Then insert 9 theta plus c. And that I've written it here. It's just a general remark. And I've said that if you're given an integral of this kind, the answer can be written as a out of b tan bx plus c. So that is seen in our example F here. In example F, I'm not wasting energy doing it because I know that it can be done mentally. So my answer straight away is 11 out of 13 tan 13 theta plus c. So let's go to another example, slightly different. This time we're looking at 13 times the integral of cosec squared 4t plus, no, dt. But what do we know about the integral of cosec from our formula? Cosec squared theta, d theta. From our formulas above, this is the same as negative cot theta plus constant integration. So that's what we are doing, but I'm looking at this point. What I'm seeing here is 4t. So I let it be u and differentiate both sides. The left side will give me du, the right side will give me 4 dt, and then make dt the subject of the formula by dividing both sides by 4. And when you do that, you find that dt equals to du out of 4. Now come back to your question and substitute. 13 times the integral of cosec squared 4t dt will be the same as 13 integral of cosec squared. Instead of 4t, we have u, and instead of dt, we have du over 4. And then the constant taken outside will be 13 out of 4, the integral of cosec squared u du. But this we know, it will give us negative cot u plus c. So, multiplying that, I will have negative 13 over 4 cot u plus c. Substitute back your u, which is 40. So it will be negative 13 over 4 cot 4t plus c. So generally, again, when you're given an integral of this kind, integral of a cosec squared dx, the solution will be negative a out of b cot dx plus a constant of integration. So, for instance, in example H, this integral can be written mentally as 10 out of 9. And the integral of cosec squared it will be negative quad. And then insert 9x plus constant of integration. So you have the answer without much work. And what I want you to know is how to do some of these things mentally, so that to reduce your workings. Because you might come across another question that requires a lot of working, and if you can do some mentally, it will reduce on your time and space and your workings. And let's look at this other question. This is not different from the first question. It's not different. We can write this answer mentally, but let's again just do it. We know that the integral of cos theta or cos x, the x is prime x plus constant of integration. But what I have here is not x. So I equate it to u. So let u be 5x plus 13. And so on the left side, du equals to 5dx. Remember that the derivative of a constant is 0. So the derivative of 13 is 0. The derivative of 5x will be 5dx. So that gives you 5dx. Now dividing through by 5, you get that du equals to now dx equals to du over 5. Which means that the integral that we are given, by when we substitute these values that we have here, we can do it. It becomes the integral, instead of this, to the cos u. Cos u, instead of dx, we'll have du out of 5. Take the constants outside the integral sign. We'll have 1 out of 5. The integral, of course, of du. And this is the same as we know this. This is sine u. When you integrate, it will be sine u plus c. And then bring back the equivalent of u, which was 5x plus 13. And you have the answer. So I stated that we can do this mentally because we've already done it before. So I know the value here is 1. So it will just be 1 out of the constant here, the coefficient of x. The coefficient of x is 5. And then the integral of cos will be sine. And put whatever is here, which is 5x plus 13. Then plus constant of integration. So we can do it mentally. And so that's how we look at how we integrate by substitution when you're given trigonometric functions. But there are various examples we look at. In our next video, we look at various other examples of integration by substitution. Look at more other examples of integration by algebraic substitution. Now, one of our videos we had looked at how to integrate using method of substitution. So we just continue with that lesson to be looking at various other examples. So I began by some 2 formulas of how to integrate here. And these formulas will be very much important to some of our examples. Now, the first formula is that, you remember in our first video, we said that the rule for integrating, if you're given a function, if you're given the integral of x raised to n dx, we said that the rule for integrating this would be x, then we add 1 to the power and divide by the new power. That new power is n plus 1. Then you add the constant of integration. We said this rule will not apply for this when n is -1. So then how do you do it when n is -1? This is the same as this. This is the same as the integral of 1 out of x, the x. How do we integrate that? And the solution is here, that the integral of 1 over x will be given as the natural logarithm of x plus t. In fact, it is important that this natural logarithm, this x be in absolute values. It's important that it is placed in these absolute values. And therefore, what I therefore mean is that if I'm given to integrate 1 out of x, the x, my answer will be the natural logarithm of x. The natural logarithm of x. Then I'll add the constant of integration. What about the integral of exponential x, dx? Now the integral of this e raised to x to the x would be given by e raised to x plus constant of integration. So these are the two formulas that I want us to begin with, so that in some of our examples we want to use them. Now, so let's look at the first example in our today's class. We're using substitution, and you'll discover that the questions we are tackling today are slightly different from the ones we tackled in the previous video. So the question is, integrate this, and this is very easy. You know what we know how to do is this. We know how to integrate x raised to any power. We know how to integrate x raised to any power, and we know that this will be x raised to n plus 1 over the new power plus a constant of integration. But what I have here is something more than that. It's not x, it's a bigger value. So what I'll do, I'll equate this, whatever is in bracket, to u. I'll say let u be whatever is in the bracket, 10x minus 2. And then after that, I differentiate this. And when you differentiate this on the left side, as we did in our previous video, will be du, and on the right side will be 10 dx. Then at this point, we would want to make the x the subject of the formula by dividing both sides by 10, and when that happens, you get the u out of 10. Now, so the question is now, how do we integrate this? To integrate this, we use substitution. That instead of 10x minus 2, we put u, and instead of dx, we write du out of 10. So what does that become? Then the integral, that integral now will be written, instead of 10x minus 2, I'm writing u, and raise it to power 5. And then instead of the x, I'm writing the u out of 10. And then at this point, we will take the constant outside the bracket, and the constant you can see is 1 out of 10. Now take it outside the integral sign. So when I take the constant outside the integral sign, what I have is u raised to 5 du. This one now, we can now do this comfortably, because we know how to integrate it. Using this rule, we can now integrate that comfortably. And this will be 1 out of 10. The integral of this will be u raised to 6, then divided by the new power, which is 6, and then add the constant of integration, so that your final answer, or the answer, not only the final answer, but the answer will be u raised to 6 out of 60 plus q. So you're only left with one task, and it's not hard, it's just substituting u, because u was not in our original question. u was not here, so we substitute u was 10x minus 2. So that means our final answer, this integral, therefore, is 1 out of 60. U raised to 6. Instead of u, we are writing 10x minus 2, then raise it to 6, then add constant of integration. So it's very easy doing this integration. And of course, I had already done this, so let me just show the steps. And the same steps I've already showed you, but let me show you how I did it. And I do it for the rest of the questions, the rest of the examples. Now, so just going through the steps again, what we want to integrate is this. This is what we want to integrate. But before we do this integration, I've said, for us to integrate this, let u be the one inside the bracket, and then differentiate on both sides. Du is 10 dx. Then make dx the subject of the formula by dividing both sides by 10, and we have dx is equal to du out of 10. Now we are now ready to integrate. You come back to your question. Come back to your question, which is here. And instead of this, write u and raise it to 5. Instead of dx, write du out of 10. Then take the constant after the integral sign, 1 out of 10, integral of u raised to 5 du. Integrate this u raised to 5 by adding 1 to the power and dividing by the new power. And when that happens, you get 1. In fact, it will be 1 out of 10 times u raised to 6 divided by 6, then plus constant of integration. From this step, you can see how I got 60. 1 out of 60 raised to 6 plus 2. So you only need now to substitute your u here with the equivalent. U was 10x minus 2. So, and this becomes your final answer. That becomes your final answer. It's very easy doing integration so long as you know the steps. Now let's look at the next example that we're supposed to do. Is almost similar. It's almost similar. So for this question, I'm just interested in this. I'm just interested with this 7x, and whatever is here is x squared. Whatever is here is x squared, and this is x. So that is very interesting, and you'll see how it will help us to how we shall do that. So let's do it. That is the question B. So again, this is what I want to do. So I'll call this part u. I'll call this part u because I want it to assist me to cancel this x. This is higher. This is x raised to a bigger power. This is x raised to a smaller power. So I'll take this to be u, so that I'll have an x in the denominator to cancel it. So let's see how it works. So let u be whatever is in bracket. Differentiate on both sides. On the left side you get it du, and on the right side you have 10x dx. And then make x the subject of the formula by dividing both by 10. And when you divide both sides by 10, you have dx being equal to du. Now divide both sides by 10x. So you have dx being equal to that. Now from there again we go back now to our integration. This is what we were supposed to integrate, and we just substitute that instead of this you write u. 7x you can see still there, multiplied by u raised to 6 times dx. Dx is du out of 10x. X will cancel with this other x. And you can see the constant is 7 out of 10. We take it outside the integral sign, 7 out of 10. the integral of u raised to 6 du. So we can now easily integrate this to be u raised to 7 and divide it by 7. And remember, this was 7 out of 10. So this 7 would cancel with 7. Then you add a constant of integration. So what are we left with? We are left with u raised to 7 out of 10 plus c. But what was u? Just go back to where your u was. Your u was 5x squared plus 7. So this is our u. We raise it to 7. Then divide divide that by 10. Then add a constant of integration. That's what I got. That's what we get when you do that. So let me show you the next one, the next example. The next example, we're supposed to integrate this. We're supposed to integrate this. And what I'm saying again, I'm saying that this one is bigger than this. This one is bigger than this. So I let u be this. I let u be the one. I let u be equal to 2x cubed minus 6x squared. So let u be that and differentiate on both sides. So when you differentiate this part, you get 6x squared, and this part gives you negative 12x. So du is equals to 6x squared minus 12x dx. Make dx the subject. Just the same way we've been doing, by dividing both sides by this. So dx will be du divided by this, and we have this. Now we go to our integral, and remember that this part it's u. This part is u, so we just replace u there. So you can see that our integral, therefore, I still have this part here. But instead of this, I have u raised to 5. Of course, that was our u. So it's u raised to 5. Instead of dx, I have the equivalent of dx, which is here. Du out of 6x squared minus 12x. We can use some just simple factorization. Because you can see that whenever I can factorize this, I have the numerator being the same as some part of the denominator. So that means if I were to factor 2 out of this denominator, then it 2 will go into 6x squared 3x squared times, and 2 would go here 6x, and that is what I have in the denominator. So what I have in the numerator. So the numerator is here times u raised to 5. This is also I'm using them to imply multiplication. Then times du. So this part is what I factored 2 out, so that this cancels that. So what am I left with? I'm left with the integral of u raised to 5 du, and this constant can be taken outside. The constant can be taken outside the bracket, and this is what I have. And this can be integrated to be a half. Just add 1 to the power to get u raised to 6 and divide by 6, then plus c. So this part gives you u raised to 6 out of 12 plus c. That's what I have. So we are left with the substituting back your u. So when you substitute back your u, which is 2x cubed minus 6x squared, and then raise it to 6, then you divide it by 12, add 3. Of course, somebody may want to leave the answer at this point, but this can be simplified further. This can be simplified further. So just show the step that I done before. So this is the part I'm talking about, that one may want to leave it at this point, but it can be simplified further. So how did I simplify? I just noticed that whatever is in the bracket can be factorized. And then 2x squared is common. 2x squared is common. So let me just show you what I did. I have, if you have 2x cubed minus 6x squared and raise it to 6, this can be written as 2x squared. 2x squared is common here, and 2x squared would go here. X, go there x times, and 2x squared will go here 3 times, and then the whole of this thing raised to 6, and then divide by 12. The whole of that thing raised to 6 and then divided by 12. Now, when this happens, you know that if I have 2 times 3 raised to 6 is the same as 2 raised to 6 times 3 raised to 6. It's the same. It's the same thing I'm doing here. That this will be the same as 2 raised to 6 x. This is raised to 2, then I raise it to 6, and it will be raised to 12. Then this other one will be x minus 3 raised to 6 out of 12. And this one is 64. 2 raised to 6 is 64. So in fact, what is 64 out of 12? This is 64. So let me just write that 64. Just write this as 64. So this is 64. And we know that 4 would go here 16 times. And 4 would go here 3 times. And so this answer here, this answer is the one you're seeing, plus constant of integration. That we have 16x raised to 12 into x minus 3 raised to 6 out of 3 plus 6. So this one I just factorized this. Although I had already said one would want to leave the answer at this point, but this answer can be factorized further, can be simplified further. Let's look at the next example, and I've done it. For the next example, we want to integrate e raised to 7x. And remember, we had already said that the integral of e raised to x, or e raised to u, du is e raised to u. So that means whatever is here, I must make it be u. Whatever is here, I call it u. So I say, let u be 7x. So if u is 7x, then differentiating on both sides, the left side will give me the u equals, so the right side will give me 7 dx. Then divide both sides by 7 to make the x the subject of the formula. And that means the x is equal to u of 7. So therefore, this integral, we just substitute back what was u, we substitute back here. And so this will be the same as the integral of e raised to u times, instead of dx, I'm writing du out of 7. because that's what we have. Du out of 7 is the equivalent of dx. So we have put it. Now at this point, as we've been doing, take the constant after the integral sign. We have 1 out of 7, the integral of e raised to u du. So when we integrate this, we already know that the integral of this will be e raised to u plus c. But what is u? U is u is 7x. U is 7x. It's 1 out of 7 e raised to 7x plus c. Now again, that means that we are in a position to do such questions mentally, so that in cases where we have long workings and this appears, we can do it mentally and reduce on the working. So what I'm saying is that there's a 7, there's a coefficient of x here, the coefficient of x here at the power, and I'm saying that how big as the 1 over 7, and then the rest remains. So that means that if I'm given to integrate n times e raised to bx, I can do this mentally, that my result will be a out of b, e raised to bx plus c. So this one you can do it mentally to reduce on low workings. So you get this constant here over the coefficient of x here. So a out of b, then e bx, then add constant with the question. So I want to do that in the next example, so that we reduce on the workings. So in the next example, our next example is this. So this next example, I can say that I have 3t as the power, and I have 5 here as a constant. So in this 5, this is now my a and this is my b. This 5 over 3, and the rest remains. This 5 over this 3, and the rest remains. But if you want to do it just the same way we did the other example, you can still do, where you would say let u be 3t plus 7. And remember that after doing this, you have to differentiate both sides to get du equal to 3dt. Now, let's look at this other example. This example can also do mentally, but we have to take e raised to 5m to the numerator. You have to take the numerator. So you can see I've taken it to the numerator. And if it was minus, when you take it to the numerator, it becomes plus. And if it was plus here, when you take it to the numerator, it becomes minus. So if I were to take it to the numerator, I would have e raised to negative 5m. So I want to do it mentally without much workings. Let this be. So what I know, this is what I have. This is what I have. This is what I have. If I have to take the constants outside, this is what I have. But to integrate this, we said that I will take 1 out of this, 1 out of this negative 5, and the rest remains. So that's what I will write. 17 out of 12 times 1 out of negative 5. And then the rest remains. The rest remains. This reduces on the working. And you can see that this is negative 17 out of 60. Negative 17 out of 60. E raised to... Oh, I left this integral. This integral sign was to disappear at this point. This integral sign was not supposed to be here, and it was not supposed to be here. So it's supposed to be negative 17 out of 60, e raised to negative 5m plus constant integration. The same thing. So if I want this to be positive, I take it to the denominator. and this is the answer. So my answer is supposed to be, if I'm wanting it positive, I would have that 17 out of 60 e raised to 5m plus c. So again, remember that this integral is not supposed to be here. So let me look at another example. Now this time I'm integrating this, and remember that we said at the beginning that the integral of 1 out of m dm would be the natural logarithm of m, and this m we are putting it between the absolute signs, and then we add constant of integration. We add the constant of integration. So for this one, it's very easy. I just took the constants outside, and the constant is 17 out of 5. When I take outside the integral sign, I have 17 out of 5, the integral of 1 out of m to the n. And this, we already know the result here. So 17 out of 5, and the integral of this one is natural logarithm of m, then plus constant of integration. So that is how we do that. That's how we do that. So let me look at this other one. Let's look at this one. Now, I want to do this. I want to integrate 7 out of 13 theta plus 4. So, I know how to integrate 1 out of u. But this one, I have to make it, I have to call it u. I have to call this one u. So I say let u be 13 theta plus 4. Then, differentiating both sides, I have du equals 13 d theta. Du equals 13 d theta, and make d theta the subject of the formula by dividing on such by 13. So you have d theta is equals to du out of 13. Now come and integrate. The integral of 7 over 13 theta plus 4 d theta, we substitute this one with its equivalent, which is u. So it's the same as the integral of 7 out of u. D theta is du out of 13. Take the constants outside the integral sign. We have 7 out of 13 outside the integral sign. We are left with 1 out of u du. This we know how to do it. So we know that this will be ln of u, the natural logarithm of u. So 7 out of 13, natural logarithm of u plus c. Now just bring back your u, because u was not in the original question. When you bring it back, this is what you have. That's what you have. 7 over 13, natural logarithm of 13 theta plus 4 plus constant of integration. Now, so finally, we look at this other one. We look at this, and this one is very easy. That we have t squared in the denominator, and we have t cubed, and then t. So we say that whenever we have this variable in the denominator, we begin by first of all dividing it. Divide it. So when you take 17 t cubed divided by t squared, and then plus 2t divided by t squared, what you get, this part will give you 17t, and this other part will give you 2 cancel 1t without 2 out of t. So that's what I say, that first simplify it as the 17t plus 2 out of t. Now, this is now what we integrate. And when you integrate this, what you get is the same as integrating 17p dt plus integrating 2 out of t dt. But this one, you know, is 17t squared out of t. And this other one, we know that is the same as 2, the integral of 1 out of t dt. So what is the answer? The answer here is 17t squared out of t plus the integral of this one's natural logarithm of t, so it will be 2 ln of t plus constant of integration. And so that is what I have as the answer. That it will be 17t squared out of 2 plus 2 natural logarithm of t. You can also use the laws of logarithm, which means this can be a power of t. And so that's what I did. That if I'm using the laws of logarithm, then the 2 can come here as a power. So that's how we do integration by substitution. Looking at how to evaluate definite integrals by substitution. And we'll have to borrow a lot from our previous videos, for instance, where we used to integrate with mentally, where we can integrate mentally between that, and I've already shown that in my previous videos. Now, so we want to look at several examples, as usual, just to ensure that you grasp the concept. So when we talk of definite integrals, then we mean those are integrals where you have limits, that we are integrating from one point to the other point. So this is the lower limit and this is the upper limit. So basically we already know how to integrate. So the only thing we are doing the only new thing is now how to bring in the integrals. But we've already shown in our previous videos how to integrate by substitution. So let's just go to our workings so that we see what we did, what I had already done. But we already know how to integrate. So there are very many good questions here, and we want to see how to approach them, especially in the time when we are dealing with the limits. For instance, I want you to take note from the very beginning that this is integrating a trigonometric function here, and look at the limits here. They are not the same as the limits we have in part C. So we'll be seeing how to treat these two because the way they're integrated is different. The limits here are different from the limits here because these are just numbers 1 and 2, and these are angles. And look at this one. This is also an angle, and this one is just numbers. So I've put these two examples, C and E, to show you how to integrate when our limits are numbers, and B and D will be helping you to see how to integrate when the limits are angles. And then, of course, I have these G and F again, just to help you know how to integrate when I have a root in the denominator, and again this. And of course, just using substitution the same way we've done before. So let's go to our first example. The solution is here. So this one we want to integrate, and we say that we would let this be u. So let u be 10x minus 2, and then differentiate on both sides. When you do that, you get that on this side you have du, and this other side you have 10 dx. That's what I have. And then make dx the subject of the formula by dividing both sides by 10. When you do that, you get that dx will be du out of 10. We are now ready to integrate by substitution. So our integral from 1 to 3 of 10x minus 2 raised to 3 can be written as this. Instead of this, I have u, then raise it to 3. Instead of dx, I have du out of 10. Then take the constant outside the integral sign. And the constant here is 1 out of 10. So 1 out of 10, the integral from 1 to 3 of u cubed dq. Now, the integral of this, you know it, then we add 1 to the power and divide it by the new power. So this is what I have, 1 out of 10. The integral of this is u raised to 4, then divided by 4, then plus constant with the equation. So this is the same as u raised to 4 over 40 plus c. Now, since we are doing definite integrals, this is not very important. You can do away with it. You can do it without this constant with the equation, because of course we'll be subtracting. So when you add it here, it will be c minus c and it will be 0. So it's needless putting it here. But I've just put it because we know that whenever we integrate with other constant, there will be time we say that it's not useful. Now, so we cannot substitute our limits at this point because we have u, which was not in the question. These limits are for the value x, the variable x, not for the variable u. So that means that you must bring back your u. Your u was 10x. So that's what I did. 1 out of 40 into bracket 10x plus no minus 2 raised to 4. The limits are from 1 to 3. Then it's now time for us to put our limits. We are now putting our limits. But this is very important that you don't reach here and put the limits that is say this is 3 raised to 4 normal. You have to first of all bring back, get rid of u, substitute the u back with its equivalent. And the equivalent of u, we said at the beginning that u was equal to 10x minus 2. So you must bring it back. Now let's put the upper limit. That's 1 out of 40. 10, instead of x, put the upper limit 3 minus 2, then raised to 4. And then this time, put the lower limit 1 out of 40. 10 times the lower limit minus 2 raised to 4. When you do with your calculator, this will be it. Alternatively, instead of expanding that to that, you just have said 1 out of 40. Then open bracket and say 10 times the upper limit, which is 3, then minus 2, then this is you raise it to 4, then now minus again it's 10 times the lower limit, which is 1, then minus 2, raise it to 4, then close the. So that this is 28 raised to 4. 1 out of 40. This is 28 raised to 4. And this is 8. 8 raised to, this is raised to 4. 8 raised to 4. And when you do this, your calculator, you get 15,260 as the answer. Let's take the next example. The next example, we are integrating a trigonometric function, and it's good to note the limits are this pi from 0 to pi out of 2. Well, these are angles. So to do this again, we just integrate the same way we did. And you see this one, to integrate this one, we say we can do it mentally. Although I've done it using the other method, now we know we can do this. The integral, we said that the integral of a cos of bx dx can be written as a out of b sine of bx plus cos of integration. Well, that means that the integral will be 7 out of 5 sine of 5x. Sine of 5x. Now, because we are doing it is a definite integral, there's no need of the constant. So we say from 0 to pi out of 2. Pi out of 2. And that's what we see here. That's what you see here. That's what you're seeing. 7 out of 5 sine of 5x, then we are doing from 0 to pi out of 2. So you can see, well, if you're doing it mentally, it becomes very easy. But if you want, you can use these other steps, like this from here, with these other steps, and come all the way up to here. But one can do this question in 2 steps. But I had already shown you that. Now, so it's now time to put our limits, because we've already found that the integral is 7 out of 5 sine of 5x from 0 to pi out of 2. So let's put pi out of 2. So that is 7 out of 5 into sine of 5 times pi out of 2 minus sine of 5 times 0, which is sine of 0. Now, so what is sine of 5 times pi? You know that pi in angles, pi is 180. Pi is 180 degrees. So what I'm talking about is sine of 5 times 90, because pi over 2 is 90. So sine of that is the same as positive 1. What about sine of 0? Sine of 0, of course, is 0. So what we have here is 1 minus 0, which is 1. And so 1 times 7 out of 5, the answer is 7 out of 5, which you can also write as 1. I want to take the root of doing this experiment because we are able to do it and mentally reduce on the questions. Let me look at the next example. The next example, this one I'm integrating. And it's very important that these are not angles. This is 1 to 2. These are not angles. So you want to see how I did it. But now to integrate is very easy now to do it. We know that it is 12 out of 7. Sine, the integral of course is sine 7x. So you can see if you're doing it mentally, it becomes just one step. Just one step thing. Now, so we have our limits from 1 to 2, and we note that they are not angles. And we also note that trigonometric functions are supposed to be expressed in radians. They're supposed to be in radians. So if I were to put the limits, these are limits, this is what I would have. I would have 12 out of 7 into sine 14 minus sine 7. But since these are not angles, when I talk of sine 14, what do I mean? I mean, when I talk of sine 14, what I mean is that the sine of 14 radians. This is the sine of sine 14 is the same as sine 14 radian. The same as sine 14 radian. What we know is that 1 radian is the same as 180 out of pi. Is 180 out of pi. So when I talk of 14 radians, I mean 14 times 180 out of pi. Because this is 1 radian, this is 1 radian. So 14 radians is 14 times that. So that's why I see, if I were to put this constant, this is what I would have. But this, to me, I read it as sine of 14 radians minus sine of 7 radians. And that's what I got here. That is 12 out of 2, out of 7, into sine of 14 radians minus sine of 7 radians. But I've just said what a radian is. 14 radians is this. 14 times 180 out of pi minus 7 radians. 7 radians. 7 times 180 out of pi. Now, this you can now do it with your calculator. And pi, this pi is the pi of 3.14 something. 3.14 something. But it's also in your calculator. It's also in your calculator. For instance, on my calculator, when I press shift, I can see there's a pi something. It's that pi. And I press shift and press pi. Pi comes. Pi comes like that. And if I say even equals, that pi gives me something like 3.14159 and so on. So that's the pi that I'm using. That's the pi that I'm using. So when you use your calculator here, 12 times whatever is here, of course this will be, what is this? 14 times 14 radians. 14 radians is 14 times 180 divided by pi. And that gives me, just a minute. Yes, 14, sine of 14 radians. It was supposed to be sine of 14 radians. So what is the sine of that? Sine of that, I'm getting 0.990607 and so on. What about this other one? This other one is sine of 7 radians. Sine of 7 times 180 divided by pi. And that is giving me 0.6. 0.6589. So what I'm doing this so that when you confirm your calculator and see whether you're getting the same things. So when I subtract these two answers and multiply by 12 out of 7, this is what I get, approximately this. If I were to write it to 5 decimal places, this is what I get. So I've just explained what I mean by those radians at this point, and I'm just saying that trigonometric functions will always be expressed in radians, so that when I talk of 14 sine 14, this means the sine of 14 radians. It's the sine of this. The sine of it. It's supposed to be sine. Supposed to be sine. Sine of this. Sine of this. Which is it? Now, so again, I go back to these other examples. They are just to make you again familiar with this type of questions. And I want to integrate this. I can see the coefficient of x is 4, so that my integral will be 4 out of 9, no, 9 out of 4. And the integral of sine, of course, is a negative cos. And then I just put 4x plus pi out of 3. Now, that is got done. We've already integrated this, and so we want the limits to run from 0 to pi out of 4. To pi out of 4. 0 to pi out of Let's begin by, let me first of all write it as 9, negative 9 out of 4, and open this larger brackets, because instead of x, I have pi over 4. So what is 4x? 4x is 4 times pi out of 4, which is pi, plus pi out of 3. And then minus cos, and then at this point, I'm now putting the lower limit, which is 0, instead of x. So this will be 4 times 0, which is 0. Then plus pi out of 3, and that's what we get. Then close the bracket. Now, what is pi plus pi over 3? This is the mass 4 pi over 3. The same as 4 pi over 3. Let me just write it as 4 pi over 3. So here's the mass 4 pi over 3. Yeah, just add. Now, so what is cos of 4 pi? And remember that pi is 180. It's an angle this time. Pi is an angle. So cos of 4 pi, that is 4 times 180, divided by 3. And that gives me negative 0.5. That gives me negative 0.5. So I have negative 9 out of 4 into negative 0.5. And what about this other one? Cos of this is same as 180 divided by 3 is. What about cos of 60? Cos of 60. And again, that one is positive 0.5. But there's a negative here, so negative 0.5. So this is negative 1. Negative 1 times negative 9 over 4 gives me positive 9 over 4, which you can also write as 2.25. What about this other example? And again, we are doing it, we are avoiding so many steps as we do this. So when we do this, we remember that the coefficient of x is 9, and we have this 2, so it will be 2 out of 9, and then the sign, the integral of the negative cos, and then put this 9x plus 7. Then if it were indefinite integral, would have added constant integration, but this is a definite integral, so there's no need of that constant integration. So this is what I got. Then this time again, remember that the limits are not angles, 0 to 1. So when I put 1 at this point, I would have 9x plus 9 times 1 plus 7, which is 16. And when I put 0, I would have 7. And I have to recall that this means the cosine of 16 radians. The cosine of 16 radians, which is same as 16 times 180 over pi. Cos 16 over 180. No, cos 16 times 180 over pi. And this other one is cos 7 times 180 over pi. Now, when you do this with your calculator, this is what you arrive at. That's what you arrive at. Of course, after multiplying that by negative 2 out of 9. Let's look at this other question. Again, this you can do it mentally. Of course, I can see the coefficient of t here is 3, so that the integral will be this constant over this constant, 5 out of 3, and the rest remains e3 raised to t plus 7. Then from 0 to 1. This one you can just put the upper limit. So of course it's 5 out of 3 into e raised to 3 t plus 7. The constants from 0 to 1. So when I put the upper limit, this would be 3 times 1, which is 3, plus 7, that is 10. And when I put the lower limit, this would be 0 plus 7, which is 7. And so this you can do, this one is on your calculator. You can do it with the calculator to get this. And I've given the answer to 3 decimal places. And the other good questions here. So let's look at these good questions. We're integrating from 4 to 1. And the auto integrating 7s over the root of 13s squared minus 2. So this again must let whatever is under the root to be u. So let u be 13 times s squared minus 2, and differentiate both sides. When you differentiate both sides, the left side gives you du, and the right side gives me 26s ds. And make the s the subject. Make the s the subject of the formula by dividing both sides by 26s. So when you divide both sides by 26s, you find that the s equals the u out of 26. The u out of 26. So let's now come back to our integral, just to substitute these values. So with the integral from 4 to 1, this is what you have been given. So I just want to substitute this for what we have. This, the denominator under the root is u. We call it u at this point. And the ds, we call it du over 26. Yes. Du over 26. So at this point, s will cancel the other s. And we take the constant outside. So when you take the constant outside, the constant is 7 out of 26. The integral of 1 over root u du. This is the same as this. This is the same as this. So bring back s. Because our u was 13 s squared minus 2. So substitute back. So when you substitute back, just create space and do that. When you substitute back here, what you'll have is 7 out of 13. Instead of this u, and remember it's raised to a half, which means squared. So instead of u, we have the equivalent of u, which is 13s squared minus 2. This is what I have here. I just took this one to the numerator. It's already in the numerator, but I think it. So I just took it 7 times 13s squared minus 2 divided by 13. Yeah, that's what I have. The limits are from 4 to 1. So when I put the upper limit, which is 1, this will be 7 13 times, this will be 13, 1 square is 1. So 13 minus 2 will get under the square root. That's what you see. Now put the upper limit, which is 4, 16 times 13 minus 2. I have 2 or 6 under the root. Then divide by 13. And that can be done with your calculator to get negative 5.9425. My answer is given to 4 decimal places. Now the last question, let's look at the last question. Just the same reasoning that I let whatever is under the root be equal to u. So let u be whatever is under the root. And differentiate both sides to get du equals to 21x squared dx, and divide by 21x squared on both sides to make the x the subject. So what you have is that the x will be du out of 21x squared. Once that is done, you go back to your integral and just do the integration from 0 to 2 of this. Substitute. Where there is this 7x cubed plus 2, what is equivalence, which is u. So under the root we have u. And the dx we have this. So you write where there is dx, write this. And x squared will cancel with this x squared. So there are constants that we're taking after the integral sign with the 1 out of 21. And so what we have at this point, when I take the constant outside, I have 1 out of 21. The integral of, from 0 to 2 of, this is u raised to a half du. That's what I wrote here. Now integrate this. Just add 1 to the power. And what I have will be a half plus 1 divided by the new power, which is, of course, 3 out of 2. A half plus 1 is 3 out of 2. Then just substitute by 3 out of 2. So this is 3 out of 2. And I have 1 out of 21 here. And we are doing it from 0 to 2. So when I divide by this, and you know that this, in fact, if I were to do it in a simple way, this is just 1 out of 21. U raised to 3 out of 2 divided by 3 out of 2. And you know that when I say divide by 3 out of 2, it's the same as saying times 2 out of 3. So this will turn to times 2 out of 2. Will turn to times 2 times 2 out of 2. So you can now see how I got 2 out of 60. You can now see that 3 times 21 is 63 and 2 times 1 is 5. And this remains. This one I have to, I have to bring back the u. Our u was that. Our u was that. So let me just write that again. Just write that. So what do we have? We had 2 out of 63, u raised to 3 out of 2, and we are doing from 0 to 2. So I just brought back this. Just brought back that, and I have 2 out of 63, and instead of u, I have 7x cubed plus 2. Remember, it's in the numerator, and then 1 raised to 3 out of 2. So this what I just wrote as, this means square root, and this one means cube root. No, cube by the power. So this is same as 2 2 out of 3, 7x cubed plus 2 cubed. But then the square root of that. So that's what you see. That's what you see. Square root because of power 1 over 2, and cube because it's raised to 3. So this is what you see. Now I'm now ready to insert the limits. I'm now ready to insert back the limits. Let me just do what I did. So now I erase that. Insert the limits. So when you insert the limits, when you insert 2, this will be 2 raised to 3, which is 8 times 7, which is 56, plus 2, which is 8 cubed. What about this other part? When I now insert the lower limit, I would have 7 times 0 cubed, which is 0 plus 2, so cubed. And so when you use your calculator, you arrive at this. And so that is how we do this definite integrals.